Have you noticed something strange about AI lately? Every few months, a new headline appears claiming that AI has reached another superhuman milestone. It beats world champions in games, it solves international mathematical Olympiad problems, it dominates competitive programming contests. On paper, AI has never looked smarter. But here's the question nobody is asking. If AI is so intelligent, why has not it transformed the world's biggest industries yet? Despite all these incredible achievements, manufacturing plants are not running themselves. Engineering teams have not been replaced by autonomous AI systems. There is a massive gap between what AI can do in benchmark and what it can do in real world. Researchers call this the AI productivity paradox. Think of it like this. Today's AI is often a high IQ toddler. It can solve incredibly difficult math problems in seconds, but ask it to manage a real manufacturing workflow, coordinate multiple software tools, and suddenly things start falling apart. The problem is not intelligence, the problem is utility. Real world work is not a single puzzle with one correct answer. It's messy. It requires planning, coordination, persistence, tool usage, handling unexpected situations, and making hundreds of small decisions over a long period of time. And that's exactly where many AI systems struggle. So how do we measure this gap? And how do we find out where today's most advanced AI models actually break down? That's where a new benchmark comes in. Researchers have created something called Agents Last Exam or ALE. Unlike traditional tests that focus on isolated skills, ALE is designed to stress test AI agents realistically. The goal is not to see whether AI can solve another math equation, it's to answer a much bigger question. Can AI create real economic value? Can it handle the complexity, ambiguity, and chaos of real world? Or are today's smartest models still stuck passing exams while failing the jobs they are supposedly preparing for? And the results from ALE reveal some surprising truths about the current state of artificial intelligence. Let's dive in. First takeaway. Benchmark success does not mean real world success. This is probably the biggest lesson from the entire study. For years, we have been using benchmarks to measure AI progress. Can it answer knowledge questions? Can it solve coding challenges? Can it pass difficult exams? And the answer has increasingly become yes. But here's the problem. Just because an AI can ace a test does not mean it can do a job. Think about it. Passing a driving theory exam does not automatically make you a Formula 1 driver. In the same way, solving a coding puzzle is not just the same as managing a large software project for months. Researchers call this the difference between abstract competence and long horizon work. Abstract competence is what most benchmarks measure. Can the model answer a question? Can it write a function? Can it solve a puzzle? Long horizon work is completely different. It's planning, coordinating, using tools, handling unexpected problems, making hundreds of decisions over time. That's what real jobs looks like. And according to the researchers behind ALE, benchmark victories have been piling up much faster than actual transformation in industries. In other words, AI keep winning exams, but the economy is not changing at the same pace. So the team behind ALE decided to ask a different question. Instead of testing AI on toy problems, what if we tested it on kinds of tasks that actually drive the global economy? To do that, they collaborated with more than 250 domain experts and created nearly 1500 real-world task instances spanning 13 major industries. We are talking about engineering and architecture, manufacturing, life sciences, education, agriculture, computing and mathematics, healthcare, transportation, psychology and neuroscience, media and visual arts, business and finance, physical sciences, and even legal work. These are not classroom exercises. These are domain responsible for trillions of dollars in global economic activity. And that's what makes AI different. It does not ask whether AI is smart. It asks whether AI is useful. Can it operate in the environments where real business create value? Can it contribute to the industries that power the world economy? Or is it still just an incredibly sophisticated calculator? The answer turns out to be far more surprising than many people expected. Takeaway number 2. The world's best AI just failed its hardest test. Now comes the reality check. And honestly, the result shocked even some AI researchers. When the team behind ALE designed the benchmark, they did not create a single test. They created 3 different difficulty levels. The first is near term, task that today's AI system should be able to handle in the near future. Then comes full spectrum, more complex workflows that require broader reasoning and coordination. And finally, last exam, the toughest tier in the entire benchmark. This is not about solving a clever math problem or writing a few lines of code. These are the kinds of long horizon professional workflows that people build entire careers around. The type of work performed by engineers, researchers, analysts, lawyers, and specialists every single day. If AI wants to become a true digital worker, this is the level it must conquer. So, how did the world's most advanced models perform? Not well. In fact, they failed spectacularly. The strongest setup tested, Codex paired with GPT 5.5, managed to solve only 8.6% of the last exam task. Think about that for a second. The best AI system available today could not even reach a 10% success rate on the benchmark designed to measure professional grade work. And it gets worse. Many popular AI agents that dominate headlines and social media discussion performed even worse. Some recorded pass rates as so low they were effectively close to zero. There's a huge gap between perception and reality. Because if you only follow AI news, you would think we are on the verge of fully autonomous companies. But AI tells a different story. The smartest AI system in the world are still struggling with the kinds of complex multi-step workflows that real business depends on. And that's why the last exam tier is so important. It's not just another benchmark, it's a measurement of the boundary between AI as a helpful assistant and AI as a truly independent professional. Right now, the boundary remains largely unconquered. The industry's biggest model may be incredibly intelligent, but according to ALE, they are still apprentices trying to pass the entrance exam for expert level work. And that means the AI revolution many people expect may still be farther away than the headlines suggest. Takeaway number 3. AI does not have a coding problem, it has a knowledge problem. At first glance, you might think today's AI agents fail because they can't code well enough. After all, if they just had better programming skills, would not they perform better? Well, according to Ailey, that's not the real problem. The benchmark uncovered something much more interesting. When researchers analyzed why AI agents failed, they discovered that roughly 75% of failures were not caused by coding mistakes. They were not caused by broken interfaces. And they were not caused by AI failing to click the right button. Instead, most failures fell into the category called understanding and approach. In simple terms, the AI did not know how to think about the problem, and that's a much bigger issue. Most of today's frontier models are trained heavily on code-centric data. Millions of repository, billions lines of code, countless programming examples. As a result, they develop what researchers call a code-first mindset. When they encounter a problem, their first instinct is to write code, even when code is not the right tool for the job. Imagine hiring an expert carpenter to repair a jet engine. They are incredibly skilled, but they are using the wrong expertise. That's what happens when AI enters many professional environments. For example, suppose an architect needs to design a component using industry standard software. A human expert might immediately open tools like SolidWorks or Rhino and use workflows refined over decades. But many AI agents do something completely different. They start writing custom scripts from scratch. They are essentially trying to reinvent tools that already exist. It's like trying to build a car from raw metal every time you need to drive a work. Technically possible, completely impractical. The AI is not failing because it's unintelligent. It's failing because it's lacked deep domain expertise. It does not understand the specialized software, ecosystems, workflow conventions, and best practices that professionals rely on every day. And that's a huge revelation because for years the industry assumed that bigger models and more compute would solve more problems. Just make the AI smarter, give it more parameters, train it on more data, problem solved. But ALE suggests the next bottleneck may be something entirely different. Not more intelligence, not more processing power, but more expertise. The future winners won't necessarily be the models that know the most code. They will be the models that understand how architects design buildings, how manufacturers run factories, how scientists conduct research, how lawyers analyze cases, and how professional actually gets work done. Because in the real world, knowing what to do is often far more important than knowing how to write another script. And right now, that's exactly where many AI agents are hitting the wall. Takeaway number 4, the rise of generalist AI worker. Most people still think of AI as a chatbot. You type a question, it gives you an answer. End of story. But if AI is going to perform real jobs, that model simply is not enough. A software engineer does not spend all day answering questions. An architect does not spend all day chatting. A financial analyst does not just generate text. They interact with software. They switch between tools. They gather information, make decisions, execute actions, and adapt when things go wrong. In other words, they operate inside a digital environment. And that's why the researchers behind ALE introduce a much more powerful concept, the Generalist Computer Use Agent or GCUA. Think of it as a next stage of AI evolution, not a chatbot, a digital worker. To explain how these agents function, the researchers use a fascinating framework that mirrors the human body. Let's break it down. First, there's the brain. This is a language model itself, the part responsible for reasoning, planning, problem solving, and deciding what to do next. It's the AI intelligence. But intelligence alone is not enough. You also need eyes, the ability to see what's happening on a screen, reading interfaces, understanding menus, interpreting diagrams, and analyzing screenshots. Without vision, an AI is basically working blind. Next comes the body. Think of this as a coordinator, the system that keeps everything organized and ensures different actions happen in the right order. Just like your nervous system coordinates your movements, the body coordinates the agent's workflow. Then comes the hands. These are the tools that AI uses to interact with the world. Clicking buttons, calling APIs, opening applications, editing files, running commands. The hands turn decisions into actions. And finally, the feet. This might sound strange, but it's one of the most important parts. The feet are the environments where the agent actually operates. Virtual machines, Docker containers, operating systems, the digital ground beneath the AI. Because even the smartest worker cannot do much if they have nowhere to stand. And this is where the industry often gets confused. Many companies claim they have built computer use agent because their AI can click buttons on a screen. But according to ALE, that's only part of the story. Researchers argue that true computer use is not just GUI use. It's not just clicking, it's also using the command line, running scripts, managing files, interacting with databases, switching between applications, combining multiple tools to solve a problem. Think about your own workflow. If you're a developer, you jump between your browser, terminal, IDE, documentation, and cloud services. If you're a designer, you move between design tools, file system, communication apps, and web resources. Real work happens across multiple environments. Humans don't operate through a single interface, and neither can AI. That's why the future is not a chatbot that occasionally clicks buttons. It's a fully capable digital colleague that can see, think, act, and navigate the entire computer ecosystem. Because if AI is going to become a true professional worker, it needs more than a brain. It needs eyes, hands, feet, and the ability to use them all together. Takeaway number 5. The most important thing about ALE is not the score. Here's the surprising part. The biggest impact of ALE may have nothing to do with the benchmark itself. Because throughout the history of AI, benchmarks have never been just tests. They have been magnets. They attract researchers. They attract funding. They attract talent. And ultimately, they shape the future of the entire industry. Let me show you what I mean. Back in 2012, there was a benchmark called ImageNet. At first glance, it looked just like another dataset for testing computer vision system. But something remarkable happened. Once researchers had a clear way to measure progress, the entire field started racing toward that goal. Breakthroughs accelerated, investment poured in, new techniques emerged, and within a few years, modern computer vision just transformed. ImageNet did not just measure progress, it created progress. And the researchers behind ALE believe the same thing could happen again. Because right now, AI research is often optimized for benchmarks that don't necessarily matter to the economy. Models are rewarded for solving puzzles, answering trivia, completing coding challenges, passing exams. But businesses don't just make money from benchmark scores. They create value through workflows, through manufacturing processes, financial operations, engineering projects, scientific research, healthcare systems, the tasks that keep the global economy running. And that's exactly what ALE is trying to measure. For the first time, researchers have a way to evaluate whether an AI can perform economically valuable work, not just demonstrate intelligence. This changes incentives because once you can measure something, people start optimizing for it. Research teams begin focusing on it, companies start investing in it, and engineers start building towards it. That's why ALE could become far more important than just another benchmark paper. It's a roadmap. A spotlight pointing directly at the industries where AI can create real economic impact. And once an AI model can reliably prove that it can handle workflows in finance or manufacturing or engineering, the conversation changes completely. That's the real significance of ALE. It's not simply measuring the future of AI, it may be helping create it. And if history repeats itself, this benchmark could become the catalyst that pushes AI from impressive demonstration to genuine economic transformation. The race towards AI's first passing grade. So where does all of this leave us? The researchers behind ALE know that benchmarks have a problem. Once a test becomes popular, AI models eventually start memorizing the answers. Researchers call this data contamination. A model may appear smarter, but in reality it has simply seen the questions before. That's why ALE was built differently. Only a small portion of the benchmark is publicly available. The vast majority remains hidden in a private evaluation pool that rotates over time. Think of it like a final exam where the questions constantly changes. The goal is simple. Make sure AI is actually reasoning, not just remembering. Because ALE is not trying to measure who has the biggest model. It's trying to measure who can perform real work. And that's what makes this benchmark so important. Right now, the world's most advanced AI systems are still struggling with many of the tasks that define professional careers. They are impressive assistants, powerful co-pilots, extraordinary tools, but they are not yet true digital colleagues. Not yet. The day an AI achieves a perfect score on the last exam will mark something much bigger than a benchmark victory. It will signal that AI has crossed a historic threshold. The transition from answering questions to completing professions. From helping humans to work to working alongside humans. From assistant to colleague. And when that day arrives, the impact on global economy could be larger than anything we have seen from AI so far. So maybe the most important question is not whether AI will eventually pass the last exam. The real question is, when it does, how much of your daily work is actually ready to be automated? Let me know your thought in the comments. What percentage of your job do you think an AI agent could handle today? And what percentage do you think it will handle 5 years from now? If you enjoyed this deep dive into the future of AI, don't forget to like, subscribe and hit the notification bell because the race toward AI, the first passing grade has finally begun and it's going to reshape the world.